We are the 1, 2, 3, go! 3 in the air, let's do it together! Exogenic!
Our planet is a dynamic one. It has been active since it formed with the solar system. Geologic process continuously shapes its surface, which has been operating in the earliest stage of evolution of the planet. The depths of our Earth unlocks bigger mysteries on how the planet shifts and moves underneath. True enough, the beauty of geologic process is not skin deep. Mountains are born from uplift rocks, rivers cut floodplains, and ocean basins become the endpoints of the sediments. With all these numerous processes happening all at the same time, we can say that the Earth is indeed evolving. But why are these processes are important? That's what we will talk about today.
Kiara, what are these processes?
Why is it important?
It is exogenic processes, and it is responsible for most changes we see on the surface of the Earth, and it plays a big role on Earth. Exogenic processes are genetically related to the atmosphere, hydrosphere, and biosphere, and therefore the process of weathering, erosion, transportation, deposition, and denudation. So let's go to the different types of exogenic process. The process under this type are sedimentary rocks. Exogenic processes are genetically related to the atmosphere, hydrosphere, and biosphere, and therefore the process of weathering, erosion, transportation, deposition, and denudation. Did you know that rivers cut big valleys, canyons, sand dunes form from wind and action? And it is part of exogenic process because exogenic processes are powered by the energy coming from the sun. Now, this may sound a bit too generalized, but all agents, example, the water and wind, need energy to be able to do work. Because sun basically powers up everything else on the surface, which allows natural phenomena. So, to be able to understand it better, let's look at how the moving water is able to modify the surface of the Earth, and hence become one of the most exogenic processes today. Water is able to move in channels, valleys, because of a difference in elevation. The water coming from the higher region, like mountains. And this water should be able to go up to the mountain, which is against the gravity. In the most efficient way is through the precipitation. This is how it goes. The sun heats up the bodies of water, and the water evaporates and form a clouds. The clouds become heavy with water vapor, then precipitation will proceed. This cycle replenishes the water that is coming from the mountain, which goes down and collects to the channels and ends up going back to our seas and oceans. And all of this process happen because the sun keeps on heating the surface of the Earth. Let's go now to the different types of exogenic process. Exogenic processes are operated on the surface of the Earth and are powered by the sun. The process under this type includes the sedimentary rock, which includes the weathering, erosion, transport, and deposition, including the mass wasting and water cycle. For weathering, it is the breaking down of rocks, soil, and minerals, as well as wood and artificial materials through contact with the Earth's atmosphere, waters, and biological organisms. There are two types of weathering. The physical weathering, that is, the rocks are broken down into smaller pieces, but the chemical composition of the rocks remains the same. Its temperature change because the hot temperatures can give rise to the thermal expansion in rocks, and cool temperatures can cause rocks to contract. In areas such as deserts, where the temperature is hot during this day, rocks get hot and expand by a small amount. During the night, the temperature can drop significantly, making it very cold, and so the rocks contract. This continuous expansion of the rock during the day and the contraction during the night extracts stress on the rock, and cracks form, eventually causing pieces of the rock to fall away. Another factor for weathering is the freeze down. The water expands when it freezes. So, when water enters the cracks in the rock and freezes, it expands and pushes the cracks further apart. When the water melts, it can travel further in the bigger cracks, making the cracks even bigger when the water freezes again. This process occurs continuously until the crack is big enough to break a piece of the rock off. And the last is the wind, rain, and waves. Wind can carry small particles or sand and rocks, such as in sandstorms in deserts. When these particles collide with rocks, they can wear them away. Rainfall can also wear away at rocks, as can the action of waves over a long period of time. One example is in the Paria Canyon, Arizona, USA. And another is located in Victoria, Australia. These limestone pillars called the 12 apostles that have been created by the action of the waves crashing against the limestone pillars. Second type of weathering is the chemical weathering. It occurs when rocks are broken down by the chemical change. Rainwater can become slightly acidic by absorbing carbon dioxide in the atmosphere, and this reacts with the mineral grains in the rock, giving rise to the new minerals and salts. Last type is the biological weathering. It takes place when rocks are worn away by living organisms. And the second under the sedimentary process is the erosion. It is the action of surface process such as water flow or wind that removes soil, rock, or dissolved material from one location in the Earth's crust, then transport it away to another location. For deposition, it is a geological process in which sediments, soil, and rocks are added to a landform or landmass. Wind, ice, and water, as well as sediment, flowing via gravity, transport previously eroded sediment, which at the loss of enough kinetic energy in the fluid is deposited, building up layers of sediments. Okay. Do you ever live in a place where you experience the effects of gravity? If yes, then chances of mass wasting can happen to your area. But don't you worry, because there are mitigating measures that we will tackle later. Did you know what is mass wasting? Mass wasting is a downslope process of transporting bodies from a higher elevation to a lower one. In layman's terms, it is synonymous to a landslide. And although it may sound correct that mass wasting is a more generalized term for all events of gravity-driven, downslope mass transportation process, which includes landslide. But how this mass wasting process happen? Why do we need to classify them into different types? And the most importantly is, how can one protect lives and properties from the effects of mass wasting? So let's go to the different types of mass wasting. The main types would just be a factor of speed. Is it rapid or slow? Rapid mass wasting occur at rates which changes instantaneously in the landform and visible to a viewer. While the slow mass wasting process would require a longer time span to have a significant observable changes in the landform. Another type of mass wasting process is the type of material. Is it rocks, soil, debris, or combination? Another one is the nature of movement. Is it by flowing, falling, or sliding?
So now, let's look to factors affecting mass wasting. First of all, again, what is mass wasting? Mass wasting involves the downward movement of materials due to gravity. So there are different types of mass wasting events depending on the material, rate of movement, and type of movement. So mass wasting processes are gravity-driven processes. So without the action of gravity, materials will not have the tendency to fall. Okay. Then again, gravity is more or less constant around the Earth, and the tendency of crustal materials would be to follow gravity. Have you ever tried to drop a pen? If you did, then you will see that the pen was pulled by gravity. So, Earth itself is a magnet, and making this a factor of less of a concern. So now let's go to the other factors affecting mass wasting. So, number 1, water. Have you ever tried to play sand in the beach? If you did, you might have noticed how easier it is to build tall sand castles with the help of some moist sand compared to dry sand. Because there is the angle of repose. So it is the highest angle that the side or slope of a mound of unconsolidated sediments will achieve under the influence of gravity. So if you use, for example, again, it is if you are building a sandcastle or something from sand, then moist sand. You will see that if you use enough moist sand, it will tend to have this base or the angle of repose. It will be significantly higher. This base or the angle of repose becomes significantly higher due to the moist sand, of enough moist sand. But if it has too much water, the grains will tend to slide past each other and become more fluid. So in this case, the angle of repose becomes significantly lower. So now, what's the connection of water and mass wasting? The answer would be fairly simple. Water, in modest and sufficient amounts, will be able to hold sediments together, which impedes the action of gravity for mass wasting to happen. In the excess of water, however, the effects could be unfavorable and allow slopes of materials to fall. So number 2, soil cover. Soil. It is basically the mixture of rocks, regolith, organic matter, water, and air. So regolith is actually called mantle rock. Soil cover is basically or very familiar to us. Then now let's go to geologic features. Geologic features include a number of factors such as the presence of structures and rock type. Structures includes beddings and other sedimentary features, joints, and faults. The presence are usually aggravating factors in increasing the potential for mass wasting events. So, for example, joints and faults provide additional concretes for water to pass through inner regions of a rock mass. Beddings and other sedimentary processes are zones of weakness in a rock unit that may increase the potential for rock masses lying on top of it to slide down when inclined.
There are 5 types of mass wasting based on their movements. is rock pulse. It involves the direct downward pull of the gravity in the absence of a surface. And it is also considered as the rapid one. Number 2, rock slides or debris slides. It involves a planar surface where materials move down the slope. Surfaces are typically pre-existing structures or bedding plants. The third one is mud flows. Unlike rock falls or rock slides, mud flows has excessive water causing it to slow down the process and cause its behavioral movement. Number 4. Number 4 is slump. It's like rock slides and mud flows in terms of their slope or surface. But it is not purely translational but has a rotational factor. Number 5 is creep. Creep is the slowest type of mass wasting based on movements. It takes months to years to recognize its changes in a surface. And we are going to talk about mitigating measures. Mitigating measures includes soft and hard measures. Soft measures include information campaign and dissemination, warning system, calamity drills, etc. that are focused on understanding and preparedness of the people near to the calamity surface. Second one is hard measures. It involves the application of engineering concepts to make a sloping mass stable. It includes installment of different structures such as shotcretes, whip holes, terracing, and concretes.
Exogenic processes are responsible for the changes on the surface of the Earth. These processes are basically powered by the energy coming from the sun, which allows natural phenomena to occur. Exogenic processes take place at or near the Earth's surface that makes the surface grow. These are very destructive. They are responsible for the creation and sculpting the Earth's surface. The different exogenic processes under this topic are weathering, erosion, transport, deposition, and including the mass wasting and water cycle.
So, on the other hand, mass wasting involves the downward movement of materials due to gravity. So, in layman's term, mass wasting is synonymous to a landslide. There are different types of mass wasting, which are factor of speed, these are rapid or slow, types of material, these are rock, soil, debris, or combination, and nature of movement, these are falling, sliding, or flowing. And there are also factors affecting mass wasting, and these are gravity, water, soil cover, geologic features, and triggering events. Now, let's move to the types of mass wasting based on their movement, which are rock falls, rock slides, mud flows, slumps, and creeps. These types of movement are basically a factor of the materials involved, the presence of a surface, and the amount of water.
Lastly, mitigating measures. For mass wasting events, mitigation involves soft and hard measures. Soft measures includes information campaign and dissemination, warning system, calamity drills, etc. that are focused on the understanding and preparedness of the community for geologic hazards. Hard measures, on the other hand, it involves the application of engineering concepts to make the sloping mass stable. This includes the installment of different structures such as shotcretes, whip holes, terracing, and coconuts.
Thank you for watching. So I am Exogenic.
I'm Exogenic.
And I am Kiara. And we are the...
Thank you for watching. Again, I am Exogenic.
I'm Exogenic.
And I am Kiara. And we are the...
Again, I am Exogenic.
I'm Exogenic.
And I am Kiara.
example of weathering, like we said. The water comes and hits the sandbank, and it breaks it down. As you can see, these are pieces that are coming from down up here, going down here. What's that process called? Good job, weathering. Okay, whoa. Yes, water. It's breaking down this sandbank right here. It's just like you have sharp cliffs that over many, many, many years, they are weathered and broken down. So sharp cliffs start to be rounded over the process of many, many, many years. Look at this process right here. Here we have, whoa! I didn't touch it. Came down, not by my force, my strength, but because of the water. The waves come constantly and hit it, and it's being weathered. Then the water will take it away. It will take it away. That process is called erosion. What's erosion? Well, erosion is the movement of sediments. Movement of sediments from point A to point B. Okay? We have different mechanisms of moving sand and sediment. One of them is wind. Oh, and one of them is water. See that it's grayish? Why is it grayish? Yeah, you're right. It's gray because it has sand particles. See the sand in my hand? Let's see what happens when it's no longer in my hand. Look. Whoa! Where did it go? Yes, it blew away. Well, who blew it away? I didn't blow it away. Well, the wind blew it away. Remember, wind is caused by the sun. Whoa! As you can see, we have a bit more of weathering down there, and it's gonna be pretty wet. Pretty interesting. Yes.
Erosion is a destructive force. Erosion is the process of taking sediments from one place to another place through certain agents of erosion, such as water, wind, glaciers, and gravity. Rain, or running water, erodes easily new soil or sand. Water from the ocean erodes sand, forming beaches. Here in Galveston, we could see that waves take away sand constantly. Murky seawater in this beach shows that the sea is moving sand from one place to another in the process called erosion. Wind erodes sand, forming sand dunes.
Take a look at those sand dunes over there.
Wind, another agent of erosion, is taking sand away from the coastline and depositing it in other places in the shape of mounds called sand dunes.
That was a fast run, right? Hey, as you can see, we have sand dunes. Sand dune. And this is sand that is being carried away, eroded by the wind, and being deposited, as you can see right here. Okay? Here we have sand.
The Great Canyon was formed because of erosion of the Colorado River during millions of years. So I decided to go down to Big Bend National Park, right down on the border with Mexico, to explore a canyon here in Texas.
Okay, so we've been studying about landforms and different landforms. And who can tell me what type of landform is this? Yes, It is a canyon.
Thanks for